sum to product vice versa. Product to sum to product. Vice versa.
This says B sum.
Whatever. Okay, the identities we're going to be using is cosine of alpha plus beta is equal to cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. It's one of them. I probably got the order of them backwards, but life goes on. And the cosine of alpha minus beta is equal to the cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. So, what do I want to do? Well, one thing I can do to manipulate the mess out of this is to take those two equations and add them up. Straight down.
How would you do
Because it comes out with something interesting. The book does a different one, but that's okay. So, if I take these and add them up, I'm just curious what will happen. This side, there's nothing I can combine because these are different. One's alpha plus beta, the other one is alpha minus beta. So you get cosine of alpha plus beta plus cosine of alpha minus beta is equal to what happens on the right-hand side?
They don't know.
The signs cancel out?
The signs are going to cancel out because one's positive and the other one's negative and they're exactly the same.
So it's just
So when you add these together, what do you get?
2 cosine.
2 cosine alpha, cosine beta. And then we just need to simplify. The idea here is to change a product, cosine alpha times cosine beta, into a sum. So if we rewrite this, divide both sides by 2, you get 1/2 of cosine of alpha plus beta plus cosine of alpha minus beta. And it becomes known as a product to sum. Now I keep bringing this up. I mean, this class is called pre-calculus for a reason. Working with cosine alpha times cosine beta is really, really hard. But working with individual cosine functions that are just added together is really, really easy. So you take it from this format of a product, which is really difficult to work with, and you change it into a format of a sum, which is much easier to work with. And that's what the power of this formula is. So, for example, if I have the cosine of 20 degrees times the cosine of 50 degrees. Maybe I should use nice numbers.
yes, please. 230, 45 or something.
No, too bad. It doesn't really matter. I'm not going to come up with the perfect answer. I just want to show you how this works. Oh, that's loud.
These Y's and 4's and stuff.
So this is going to equal 1/2 of. Now you got to be smart about this. If it's alpha plus beta, that's no big deal. It's the alpha minus beta that you have to worry about. And with cosine, it really doesn't matter if you have a negative angle in there, but it's always better to write it as a positive. So you can think of these two pieces up here being able to commute. So it doesn't matter if you write it cosine 20, cosine 50, or cosine 50 times cosine of 20. So when you get down to the alpha minus beta, what angle should go first?
The big one.
The bigger one. So this would be cosine of the sum plus cosine of the difference. And I would put the bigger one first, just to keep it positive. So this becomes 1/2 of cosine of 70 degrees plus cosine of 30 degrees. And it's much easier to work with it that way than as a product. Now there's sometimes you get fancy angles up here so that you can calculate both of these. Right now we can only calculate cosine of 30, cosine of 70, you'd have to type into a calculator. But I mean, that's the gist of the formula. The book is going to do it this way. Cosine of 4x times cosine of 7x is equal to, well, what's it equal to?
1/2 of cosine of 11x plus cosine of 3x.
Oops, I almost put pi there, 11x plus cosine of, what was it?
3x.
3x. And it makes a nice easy separation. All right, there's 4 formulas based off of this. They're on page 263. So they'll have sine alpha times sine beta, cosine alpha times cosine beta, sine alpha times cosine beta, cosine alpha times sine beta. But they're also on that little sheet that I handed out to you. They're all there. So each and every one of them is from either the sum of the cosines or the sum of the sine angles. They're all derivable, so they're pretty simple. Yeah, they're on the back side. All right, what if we want to go the other direction?
We don't want to.
I usually don't. Like I said, this is a quick topic. To go the other direction is a little strange. New one. We're going to want to take a sum and break it down into a product. But to do that, these things have to be 2 pieces, an alpha and a beta. So what you do is you start off with something a little strange. And you choose your 2 angles to be the sum of 2 angles divided by 2, and the other one to be the difference of 2 angles divided by 2. So I'm setting it up as a product part of the formula. And then we use the rest of the formula, the product to sum part, which is cosine of what?
Let me see.
If it's cosine angle times cosine angle, what do I do with my 2 angles?
Adam?
You add them for the first one, and then the second one you...
Is it supposed to be a 2 in front of the first one? Was it 2 in front of the first one on the sheet?
Oh, here?
Yeah.
Not. I'm just doing the product to sum formula. Did I leave a 2 on
This
it?
is sum the product one? Yeah,
No, I'm doing product to sum right now. I'm still up here. I'm still doing those formulas. I'll move the 2 over eventually. But what I'm saying is, instead of alpha and beta, we're putting alpha plus beta over 2 and alpha minus beta over 2 as our angles. So when I bring it over into the sum part of it, this first angle becomes the sum of those 2. So it becomes alpha plus beta over 2 plus alpha minus beta over 2. Plus, and then the second one becomes cosine of alpha plus beta over 2 minus alpha minus beta over 2. And a bracket. And just see what the heck that does. This is one of those little mathematical tricks that there's no rhyme or reason why we're doing it. It's just because it actually works. Someone backtracked this and figured out how to go forwards with it. It's kind of messy. So what happens to these 2 when you add them together? Well, you get alpha plus beta plus alpha minus beta in the top.
So you get 2 alpha.
All over 2, which becomes, you get 2 alpha over 2.
It's just alpha.
It's just alpha. So this becomes 1/2 cosine of alpha plus, when I add these 2 together, it's going to be alpha plus beta minus alpha plus beta. Now you got to distribute that negative sign. So alpha minus alpha is going to give
It's
me
gonna be
0.
2 beta.
It's going to give me 2 beta over 2.
So it's just beta.
So it becomes cosine of beta. So now if I manipulate it right, I have cosine of alpha plus cosine of beta is equal to, move the 2 to the other side, and you get 2 times cosine of alpha plus beta over 2. Cosine of alpha minus beta over 2. And this becomes known as a product to sum formula, or I'm sorry, sum to product formula. And they're not, this one's not used as often as the first one, but it's still kind of cool in a weird way. If this is, for example, cosine of 2x plus cosine of 3x, it becomes equal to 2 times cosine of
2x plus 3x.
all over
So it's
2.
5x over 2.
Times cosine of
X over 2.
x over 2. Because then you would subtract it, big one minus small one, I would always go, and you get x over 2. So we've changed a sum into a